Hello, I'm Jordan Bongo, and this is an Oakland Weblog how-to tutorial. This is going to be the second part to how to read the radar. In this video, we are going to focus on velocity interpretation. Velocity is a massively important topic when it comes to radar. It helps us see if storms are gaining strength or losing strength, and if there's rotation. So first off, we'll start off with how a radar sees wind. This is going to be the fundamental basics of everything else in this video, so we're going to get this down. So when the radar sees things in a circular way, that is, it doesn't see things as north, south, east, west. All it sees is stuff going from the radar or to the radar. So we can't determine if wind's going side to side from the radar just from one scan. So, but we can see in one scan if it's moving towards or away from the radar. And if it's moving away from the radar, we assign that as a positive direction. But if it's moving towards the radar, we assign that the negative direction. So to make that a little more concrete, we're going to go through these examples here. We're going to take these 8 points here and assign a uniform wind vector to the north. Okay, so first off, we'll start at the point to the north. The radar would see the wind going to the north in this case because it's moving in the same direction as it, and it would see it as the same speed. Now as we move to the south of the radar, we will see a similar pattern emerge since it's still in line with the radar moving towards the radar. So now we'll look at the right side of the radar. As you can see from that point, we don't see any velocity from this. That means because the wind's traveling perpendicular to this, so we don't see any wind speed. And the same goes for the point on the left side of the radar. Again, it's traveling perpendicular. Alright, so we will now talk about this point on the bottom left hand side. This is an interesting case, as are the other 3 points remaining. So, you see the wind's kind of coming towards the radar for it, but the radar doesn't sense that it's also getting closer to the radar. So all you see is wind's going towards the radar, but not as fast as the actual wind speed. And the point on the bottom right will just be mirrored it, because again it's the same radius and uniform wind vector. And now the final 2 points will start with the top left. So this is going to be very similar, except the wind's going to go away from the radar. So you see here, and same follows for the top right. So this is the basics of how a radar sees wind. Next, we're going to start getting into the meteorology of all of this wind talk. We're going to start with a concept called divergence. Divergence is when wind is flowing away from one another. This oftentimes is used in meteorology to determine if we're going to get updrafts or downdrafts or neither. So divergence depends on which tilt you're looking at, but most commonly you'll be looking at the bottom of the storm, and divergence means the storm's weakening. That is, that it doesn't quite have the upward forcing to bring up precipitation, make hail, or stuff like that. As you can see here, green is normally assigned as winds going towards the radar, and red is normally assigned as wind going away from the radar. That's the convention we will use here. You can see the L's are going away from one another, so that means we have divergence here. But one caveat, you can't just look for this green-red signal anywhere. You must know the radar location, and must know the color table associated with the wind direction, so you can actually say for sure if it's divergence or not. Now we're going to talk to a kin of the divergence called convergence. And you can see here, it's basically the opposite of what we had earlier. Convergence is normally signals of storms that may be increasing in intensity, dropping larger hail, and such as you have wind forcing precipitation upward in a cloud. But again, you must know your radar location to know for sure if it's convergence or divergence. And finally, the one thing everybody associates with velocity, that is rotation. Now rotation, again, you have wind going away and wind going towards the radar because that's the only thing the radar sees. You have red going, you see how it's rotating. This is what we call a seal. It's not necessarily an indication of a tornado. However, seal normally indicates there's some degree of rotation happening inside the cloud. So as if it's a mesocyclone or a supercell, as you've commonly heard, or if it's just a storm, a normal thunderstorm. So this is pretty straightforward, as most of you have seen it again. But one important thing to know is that on a mesoscale, or the scale you normally watch storms on, this rotation can either be going clockwise or counterclockwise. And again, know your location so you can know for sure if it's rotating or not. Okay, now we're going to get into a little bit touchy topic. Not so much touchy as it's just normally obscure topic or something like that. And that is that of storm relative velocity versus base velocity. Storm relative velocity, what it is it's the storm's movement, the wind in the storm subtracted from the actual movement of the storm, so you're seeing just the storm wind inside the storm and not its movement. But base velocity includes the storm's movement, so you see that in there too. So what do we use these two products for? Well, storm relative velocity is normally used for helping us spot tornadoes, as we want rotation relative to the storm, and if not, you will not always have wind speeds great enough to overcome the storm's relative motion in base velocity to be able to see if it's a tornado or not. You may just see two greens together. Now, base velocity is handy when determining microbursts and downburst signatures, or straight line winds even. Now, microbursts and downbursts, what those are, that's going to be the divergence we've seen taking place for the most part. And then straight line winds, it will be bright colors there. Now, to wrap this up, here's some important conditions to remember when looking at radar. You must know where the radar is located at. This is so you know which direction the wind is blowing, and the outbound winds and inbound winds, when you choose different radars, will be different colors, and thus different signatures on radar that you are looking for. And then finally, beam height matters. So basically, as you get farther away from the radar, the storm appears high off the ground, or the beam that scans the cloud is high off the ground. So you aren't always getting the lowest part of the cloud when you scan it with a radar. So basically, you have to assume that as you go down, winds will get weaker with height due to the frictional force. So just keep these things in mind if you're ever looking at velocity products. And remember to connect with us on our Facebook, Twitter, YouTube, and our website. Thank you for watching this video.